Hey, g'day, it's Presso. Thanks for joining me in the workshop today. We're working on the Titan engine again, and we're getting very close to the end of this project now. One of the important jobs still to be done is to arrange for the fuel metering, which is partly to do with a small needle valve and spray bar assembly which fits across the venturi, and we also have to drill a hole lining up with that venturi and travelling through into the centre of the crankshaft. Now the crankshaft is hollow, there's a hole back in here, and when that hole lines up in the correct position, which is 45 degrees before top dead centre, it allows fuel and air to travel down through that hole and collect here at the back of the crankcase. Now the fuel air mixture is stored there, and when the piston is in the correct position, it allows for that fuel and air to travel up through this projection here on the side of the crankcase and be admitted to the top of the cylinder, and once that's ignited and burnt, it travels back down and comes out through the exhaust port. Now the real timing of this engine is done here with the piston and the liner. So it's the equivalent of what you would find in a four-stroke engine with the camshaft and the valves. What we're doing at the front here is less critical. It's just a very crude way of getting fuel and air mixture into the engine. But we're going to do that later. What I'm going to do first is show you this little sticker. Now this came from a gentleman named Jay Miller. Now Jay lives in North Texas. He's got a very large workshop over there, and he does a bit of everything. He does some amateur radio, some model railroading, does woodwork, photography, and I'll put a link to his channel up above and in the description below, and that's worth checking out. We'll get this up on the board in a minute. And oh, you like my new apron? I figured if it's good enough for Tom Lipton and Blondie Hacks, it's good enough for me. And one of the things I found interesting was that now I'm working at home here, I'm no longer working as a shop teacher. I don't wear an apron. It annoys my wife no end. But one of the things I found was that I'm constantly looking for simple tools. So I was always looking for a pencil and a marker, small steel rule. There were just so many tools that I used to be able to carry in my pockets when I was teaching. So I used to wear one of those sort of dust coats, had big pockets, and everything I needed during a lesson was there. And in fact, sometimes you had to clean your pockets out at the end of the week because I was so full of stuff. But one of the most useful tools that I had when I was teaching is this one here. This is a Gerber multi-tool. Now my wife bought me this as a gift many years ago, and it's never let me down. It's one of the most useful small tools to carry in your pocket when you're doing anything. And one of the things that kids found interesting was when I whip this thing out and open it, and it's done by just flicking it like that, and it used to entertain the kids no end, and they'd always want to have a go at doing it. And unfortunately they never got the hang of it. If you gave it to them for the first time, they would sort of lock their wrist and do that, and of course it wouldn't open. The real trick is to hold it very loosely in your hand and just flick it, and it comes open like that. But these pliers are the most useful thing. They're incredibly strong, and given that they're retractable, it's surprising how effective they are. But I'm going to keep that in this top pocket here all the time now. I've got my pencils and my markers, my small rule, and it's just handy to have all this stuff around the workshop. The downside is that it's hot. So in the summer, this is that wax canvas, and it doesn't breathe very well, but it is very hardy and durable. So you see me wearing this a lot more. And the other thing I've done recently is I bought a map of the world. I'm going to put that up in the workshop, and I want to be able to record the places that I get emails and communication from. Now in the last couple of days I've been talking to a gentleman in Fairbanks, Alaska, and that's a place that's very exotic as far as I'm concerned, and it's nice to be able to record where you've had those conversations all over the world. And for me, being a bit of an older nerd, the ability to be able to do this is mind-blowing, and I love the fact that you can just jump on the computer and talk to people all over the world, and you have that common interest. So you'll see that in the workshop. I'll get that up soon, and maybe you'll see your little pin in the map, and it'll remind you that we had a chat. Now I've got some other mail that I want to show you, but let me get the sticker up first and we'll go from there. There's Jay up there right at the top. Hope that's straight. There it is, Crawford, Texas. Check it out. Going back a couple of videos ago, I was having a bit of a whinge about not having any thin parallels, and one of my viewers very, very kindly sent me this set. These are the little wavy parallels, and I've been wanting a set of these for a long time, and he was kind enough to send me these. Now, I don't normally ask for gifts in this channel, and I don't expect gifts from my viewers, so when he asked me if he could send me these, I thought it was like an old set that he had, and they were just lying around, excess to his requirements, but these actually turned up direct from the supplier, and they're brand new. So thank you very much. He asked me not to name him directly, but I truly appreciate that. But like I say, I don't normally ask for gifts, and well, it's just nice to think that people appreciate what I do, but I certainly don't expect it from my viewers. Now, the other thing I want to show you is this. Now, this is not a gift. I bought these. Haven't opened them yet. And this is something that I mentioned a long time ago. I was doing a job and somebody said, you need to have a set of transfer punches. And I said, yeah, I'd love them, but every time I went to buy these, I needed a metric and an imperial set. And every supplier I went to would have either the metric or the imperial, but not both. And the same thing happened this time. And I ended up having to buy these from two separate suppliers. They look identical, actually. The same kit, just one set's metric, one imperial. And this is that's the imperial set there. So I think these are useful, but they're not. I don't think they're as accurate as setting something up on a milling machine. But yeah, we're going to have a look at those shortly in relation to the Titan engine. And here's the other set here. And like I say, these came from different suppliers, but same manufacturer, I'm guessing. So there's the packaging, identical. This one's from Aussie Machine Tools. I forget what this one was, but definitely a different company. So there you go, I've got both sets now. I suppose I shouldn't be complaining anymore. Okay, let's have a look at the engine. Now, the reason I bought these punches is that in the build notes it says that you need to put the appropriate size punch down through the centre of the venturi and let that rest on the crankshaft itself, and then position the crank pin on the crankshaft until it's 45 degrees before top dead centre. So if you visually align with that crank pin with that hole there, that's the correct 45-degree rotational angle. And then it says to just put that down there and tap that with a hammer. Now, the problem with that is that the punch mark would raise a burr on the surface of the crankshaft, and then when you try to remove the crankshaft from the back of the engine, that burr would drag all the way down the inside of the bronze bush. And almost certainly it's going to damage the bush and leave a score mark in there which you'd have to then try and fix. So I don't want to do that. And the other problem is that the point on these punches is very, very short. So I don't know if you can see that, but there's not a lot of length in that point there. And if I was to place that on a metal surface and then tilt it over at 60 degrees, it's really the edge of the punch that's touching and not the point. So I don't know if that's a viable method for doing this. I've got another way, and I'll show you that now. Okay, this is what I had in mind now. I said we need to hold that crank pin at 45 degrees before top dead center, which is roughly where it is there now. And what I want to do is put a drill sleeve down inside the venturi. So this is a piece of silver steel, like tool steel that's been hardened and tempered, and it's drilled for 1/8 of an inch. So I can slip that in there, and that's a brand new 1/8 inch jobber drill. And I can put that down into the bore of that sleeve and just simply drill into the crank shaft. Now, it's entering on an angle, so it's unlikely to make a really neat hole in the crankshaft, but what we want is a position that we can later on set up in the milling machine and drill through. But if I was to do that, if I was just simply to hold the crankshaft where it is now and try to drill that drill bit into the crankshaft, it would almost certainly try to rotate the crankshaft. So what I've got is a little 3D printed fixture or a jig, and that tubular section there fits over the crank pin like that, and then it's just a matter of aligning the drilled holes. So I'm going to get that set up there, put in a couple of screws, and that's going to lock the crankshaft in that rotational position. And then I can go ahead and drill without any worries about the crankshaft moving. So I've also removed the propeller and I've put on a Delrin sleeve there, the same thickness as the propeller, so I can tighten up the spinner, draw the crankshaft all the way forward, so that when we do drill that hole, everything's going to be lined up. So let me get this set up and then we'll have a go at drilling the hole. There's sort of no easy way to clamp this down. I'll just put it on this bit of cloth here and that's going to cushion it. See how we go. Alright, it's made a mark. Pretty sure that that's good. I'll give it a bit more. Alright, I can see down at the bottom of that now, and it's actually made a full circular mark around where the tip of the drill was drilling in there. So if I take the crankshaft out now, that will give us an accurate register for the next step. And of course, the important thing now is the crankshaft going to come out? Or have I still managed to raise a burr where I drilled that hole? If there is a burr there, it's going to be relatively minor. Oh, it's actually sliding out quite easily. So I'm going to try and take this out without sort of rotating it side to side. Yeah, it's actually, I can feel that there is a burr there, but it's got to be fairly minor. I just got down in there with one of these long Cratex points, and that seemed to do the trick. Alright, so you can see that little dimple there, and what we need to do now is enlarge that with the drilled hole that goes right through to the centre of that bore there. This is the setup now, so I've got the vice jaws snugged up on the crankshaft, and I found the centre of the vice jaws just using an edge finder and the half function on the DRO. So the spindle now is over the centre of the crankshaft. And then what I've done is I've used one of these little centre finders, and you can set these while the spindle is running and just hold a pencil against that point there. And when you take the pencil away and it runs true, you've got it set up. And that point is directly under the centre line of the spindle. And what you can do then is, just by trial and error, you can position that and actually drop it into that dimple. Now with the spindle running, if you drop it into the dimple and raise it again and it's still running true, you know that you got the centre in the correct place. If it comes out of the hole and wobbles, then you've got to adjust things. You've got to adjust the actual position of the crankshaft, a rotary position. You can't change it in Y, you've actually just got to rotate the crankshaft. And you can of course adjust X until you get it right. So I've got the vise snugged up now, and what I'll do is I'll use a centre cutting 5/16 end mill to drill that hole. Now in the notes it doesn't specify what this diameter has to be. It just says drill a hole 90 degrees at that position. Now the venturi is 3/8 of an inch. If I go to 5/16, it just means that the port will be uncovered at about 9 o'clock on the crank disc, and will close at around about 12 o'clock. If I go for a bigger diameter hole in the crankshaft, it will open a bit earlier and close a bit later. So I figured that if I started with 5/16, I can always make it bigger. I'm fairly happy that the engine will run with this diameter hole in the crankshaft. So it makes me think that there's, all of this is a bit rubbery. If it was really, really specific, I'd do that, but it's not. So we're just going to try 5/16, suck it and see, see how we get on. Now, if you're wondering why that took a while, I was trying to raise the knee and the camera was in the way, so I had to keep positioning the handle so I could get at it. So I had the table locked in X and Y, and I had the quill locked, and I just raised the table to do that. Now, that's got a really nasty burr on it because that end mill was a bit blunt, like all my Imperial end mills. So I'm going to clean that up and then we'll put it back in the engine and see how it looks. Got that hole cleaned up. I was really surprised at how much metal got displaced by that end mill. There was quite a raised ridge all the way around the hole, and I got at that with a needle file, filed off as much as I could without scuffing the surface of the cylindrical part of the crankshaft itself. Then I changed over to using a precision ground flatstone. So with that I could just simply roll the crankshaft over the surface of the stone, and you could sort of tell by looking at the polished areas where the displaced metal was, and you just kept going till all that was gone. So these flatstones were sent to me by John Creasy, and I hadn't used them before. That's the first job I'd actually used them on, but they're great because they don't cut into the underlying metal. It's not ideal to do it on a cylindrical surface. It's better on a dead flat surface, but it's better than using a file or emery cloth or anything like that. So I can put that in there now, and on the back of the crankcase here I've mapped where the port starts to open and where it closes. So it's opening here at about 8 o'clock, closes at about 1 o'clock, and you can look down through the venturi there now, and if I put that about halfway, yeah, the big hole, and if I bring it up a little bit higher, you may be able to see there, it's just starting to close. So I think what happens here is that that port is open during the cycle when the piston is ascending, when it's going up into the cylinder liner. And what that does, it creates like a low pressure in the crankcase. But because that port is open, it can draw air and fuel past the spray bar. It's all now contained in the back of the crankcase. When the port closes, the piston is now starting to descend. As it comes down, it pressurizes the crankcase, and then that high pressure is held there until the transfer port opens. And at that time, the fuel and air mixture rushes up into the cylinder. All right, what we need to do now is get on and drill a hole for the spray bar, both sides, and see if we can tackle that. Okay, here's the setup to drill this one single hole, and this has taken about 3.5 hours. And you know, if somebody said to you it takes that long to drill one hole, you'd call them mad, but this is what it takes to get it. So what I've got is an angle plate which is bolted down to the milling machine table. I've set the angle of the plate relative to the front edge of the table to 60 degrees. I just used one of these angle gauges here and an engineer square to get it close. And what we have to do here, and the problem is that you can't get at the hole that we're trying to align with. So what you do is you project the hole by putting a piece of steel rod or a gauge pin or whatever you've got into that hole. Now I didn't have anything that was a good tight fit, so I machined up this piece of brass and I tapped that in. That's how tight it has to be. And then I run an indicator across the top of the brass rod and across one edge of the brass rod. And then I tapped everything in until I got that indicator reading 0 both ways. So in theory now, our drilled and reamed hole through the venturi is aligned with the y-axis of the lathe, and it's square to the x-axis. And I've run an indicator down on that brass rod now, and I've just swept out both sides and found the center. I've set the DRO at that position. And what we should be able to do then is offset down to this little projected boss, align with that and drill a hole. Now, I was full of confidence, so I went ahead and actually cross-drilled this little brass throat piece at 4mm diameter. And if we drill this at 4 as well, when I insert that, is it going to line up? Probably not, but we'll give it a go. If it all goes bad, I'll have to make another one of these and just drill it in situ. I'll drill it in place and then it's all done. But just for the exercise, I wanted to try this. So let me get set up for the next step and we'll have a look. Okay, I've got the camera set up basically directly in front of the column of the milling machine. And you can see my problem. This pin in the collet chuck is the same diameter as that projected boss on the casting. It's aligned at the back and the front, but as you can see here on what is my left, it's offset by about 1mm, and it would be the same on the other side. And of course, it could be even worse underneath, we don't know yet. If I drill a hole there, it should be exactly on the center line of the previously drilled and reamed hole we used to make the venturi. If I offset and drill in the center of that projected boss, then the hole will pass through the venturi closer toward the front, and of course there's no way this little brass piece is going to align with that. So I'm just going to have to suck it up and drill a hole there. Could be the casting that's wrong. It's more likely it's something I've done wrong in previous setups, but we're just going to have to go ahead and do it. It's not the end of the world though. I can CNC machine that boss and make it concentric. It'll come out a little bit smaller, but I think there's enough metal there to be able to do that easily. And we'll have to do the same on the other side, of course. So let's get set up, drill the hole, and move on from there. The joys of machining. What I'll do now is mill the top off that boss there and reduce its height. There are no dimensions on the drawing for these parts, so if I come down a bit where it flares out where the fillet is, that will give us a bit more material to work with when we do the CNC milling to make that concentric. And let's hope the back is better than this side here. It looks even worse. Anyway, we'll get it off there now and see how that brass piece, the throat piece, lines up. Okay, let's see if we can fit this now. I know you realise I've already done this. I mean, you're not stupid, and I wasn't willing to commit to this and then see it all fail. So I did try it. So what you see now is a dramatic recreation. So we're going to push that brass throat piece in with the holes roughly aligned, and we'll push that down until we can see the holes roughly aligned. You probably can't see it. I'm going to push the tapered end of my scriber in there, and this is a number 22 drill bit, which is slightly under 4mm. There it goes, that's gone through. And this is a 4mm transfer punch with a tapered end on it. Now these are a little bit less than 4mm. As you can see, that's gone through no trouble at all. So there you go.
Like a boss.
Yeah, look, enough of that. Let's not get too excited. Still got to deal with this train wreck here. Now I said I was going to CNC machine that, and the advantage of that is that I could do a 3D toolpath and I could contour the outside of the boss and also follow the curvature of the venturi. And I actually made a toolpath. I went to try it out this morning and then found out that my CNC controller is kaput. The Y-axis is no longer working. The controller that I have is over 13 years old and it's faulty. What I'm looking to do is upgrade all the electronics and make it a more modern modular unit, but getting the parts in a short period of time is going to be difficult. So I may end up having to do this on the lathe or in the Bridgeport on the rotary table. I can contour the outside of that projection there, but I won't be able to follow the curvature of the venturi. But I still can make it work. Now with that throat piece, I can't fit that permanently until I've done the taper turning at both ends. So I made this little tool to extract it. and it just hooks onto the bottom of the brass piece like that, and you can pull it out. After I've taper turned both ends of that throat piece, I won't be able to use that tool. So it's going to get pushed in. It's pretty much going to have to stay there unless I can sort of blow it out with compressed air or something, which I doubt. Could possibly get in there somehow and hook the edge of this little hole, but it won't be easy. So when I've done that taper turning operation, we'll put it in and leave it in. When we come back in the next episode, and yeah, I'm going to cut this off now, and you're probably thinking, well, didn't get much done today, we drilled 2 holes. But that's the nature of doing this sort of work. There's tons and tons of setup. The actual processing time is very short. But when we come back, we're going to make the spray bar and the needle valve. So I've got some hex brass bar stock for the spray bar, and I've got some 2mm silver steel for the needle valve itself. And both of these parts have to be absolutely concentric. If you get the needle valve and it's sort of slightly out of alignment, as you rotate it, it will oscillate and you won't get an accurate fuel metering through the spray bar. So it just makes it very hard to tune, because you turn it a bit and it might go lean, you turn it a bit more and it goes the other way, and it's just very frustrating. So you're going to have to be very precise with that machining. Now, the other thing I want to tell you is I mentioned in the last episode that the patents had turned up. The owner of the patents was looking to sell them, but he's changed his mind. He's gone on and approached a foundry, and the foundry is looking to replicate the castings for him. So he told me, keep me updated, and if I find any more information, I'll let you know. So yeah, that's it for today, guys. Thanks for joining me in the workshop today. I really appreciate you turning up, and I appreciate the comments that are being left. I'm doing my best to answer the comments, but there's just so many of them. So please, if I haven't answered your comment, it's not because I'm ignoring you, it's just that I haven't got to it. So see you on the next episode. Like I say, getting toward the pointy end of this now. It's getting very exciting. So it's Prezzo signing out. See ya.